How do we work with it? You're going to find out that most of the material that we're dealing with today, the math that we do is relatively easy. What's weird about it is the fact that you have to bounce between a couple of different formulas and reset things up to make sure you understand exactly what you're working with. Formulas themselves are not that bad, just a little bit different lingo. So an arithmetic sequence or arithmetic series, basically that's going to be defined as having any sequence that has a common difference between them, or a common sum. For example, if I start with something that goes 2, 4, 6, 8, 10, dot, 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 dot. Is there a common difference between each one of those? 2, okay? Each time, you're adding 2 to it. 2, yeah. You're adding the same value to it. If it was going the other direction, you could be subtracting the same value to it. So an arithmetic sequence or an arithmetic series is something that has a same common, they always call it difference. But remember, that difference could be a sum or a difference. Does that make sense? You've seen this before. For example, which one of these, or are they both, arithmetic? First one is, right? What's the common difference? 4, okay. So what we do here when we identify these, we notice that the same difference going between each one of them is you're adding 4. So you say your difference is 4. What's the first term in that sequence? -3. So what we do here is we identify the common difference, and we also identify the first term. We use subscripts. A sub 1 means that the first term in that sequence is -3. Hence why the 1. Okay? Now in the second one, it goes up by 3, 5, 7, 9. There's a pattern there. You would be able to tell me the next values within the sequence and all that stuff, not so much of a hassle. But it's not an arithmetic one. There isn't a special pattern that's occurring, like a special arithmetic pattern. Okay? So we don't work with those. We work with these, because these are easy. So what happens here is now we're going to use that sequence to show you guys how you can write out what they call the rule for the nth root, or nth term. Here's what that means. I can say that any number in a sequence, a sub n, that means the nth number, whatever it could be, the 13th, the 50th, the 473rd, that value n, will always be equal to the first term plus whatever number you're looking for, third term, fifth term, 703rd term, minus 1 times the difference. You might have seen that before. You might have. I don't know if you have, you might have. So this is the rule for the nth term. First term plus n minus 1 times the common difference. So if I'm looking at that first example of the sequence, we had a common difference of 4. Let's say I want to figure out what the 63rd term is in that sequence. So what I'm looking to find here is, what is when n is 63? Exactly. So it's going to be the first term plus 63 minus 1 times our difference. Well, our first term was -3. That's why it says 4. So the 63rd term within that sequence becomes, we're pushing it away, Mr. Prime, what do we got? 245? 251? 245. It's only 11:25.
Oh my gosh, that would be so
Is it 245?
nice. It's the golden number, baby.
So if you counted out and kept adding 4 to that, you would eventually get to 245.
Wow.
Okay? Yeah. And I just made that up off the top of my head. What? Oh, yeah, sure.
I have a formula as well.
It's, you take whatever number you're looking for, which number within the sequence, subtract one, and then multiply it by that difference. I forgot how this was derived. I can look that up and show you how they did all that. It's a lot of algebra proof.
My dad was really just like, hey, this works.
Yeah, that's pretty much it.
Okay.
Hey, Billy, look what I can do! That's what Pythagoras said to Socrates.
Billy, so crazy.
His nickname was
Thank you. It's Socrates. Bill and Ted's Excellent Adventure, Socrates.
Oh, yeah.
Thank you.
never seen it.
I told you you had to watch that movie.
I know, and I did, but I just literally forgot.
Sure you did.
Tell your two guys that are in your head, Bill and Ted's
Mr.
Excellent.
Murphy, I told you yesterday, I don't know if it's just two.
Tell however many are in there. Say
I'll
group.
voice my opinion, but they don't know if it's two.
So here's what something like this is going to look like. They're going to ask you to write out the rule for the nth term, which means you're going to use you're going to write out the formula in the as most basic generic as possible. So again, we have a sequence of 50, 44, 38, 32. So is this sequence moving up or down?
Down.
So is my d value positive or negative?
Negative.
Okay. So our d value here would be negative 6. Excellent. And what's your first term? Okay. So what we need to do is, first of all, bless you, write it out in terms of a sub n. We start by the formula. I recommend writing it down a couple times. You'll commit it to memory. The nth term is going to be the first term plus n minus 1 times your difference. Well, fill in the blanks. All you do now is distribute the negative 6 and combine like terms. So we have 56 minus 6n. The common way of writing it is always to put the first, the a sub n first, or not a sub. This is not the first term, but you put this value first, you put the n value after. That's just the common way they write it. Yes, ma'am. Great question. What's that? Right. What we did here is the first part. Write the rule. Here's your nth rule. And now, to find the 20th term, the 20th term will be 56 minus 6 times 20. Negative 1 times negative 6 is 6. 50 plus 6 is 56.
Where's the 20 come from?
The second part of the problem.
That's a 20?
So there's different
Yeah.
parts.
It's a 20 period.
Oh, I see.
Find the 20th term.
Oh.
What was it?
Negative
Good.
6.
Again, what's going to happen? Yes, ma'am.
So if I didn't do that first part, can I just do the second part?
If it asks you to write out the rule, then it means there's part A and part B. That's all. What's going to happen here a lot of times, you can get to the second part without doing the first. But what's going to be weird when we get to the more complex style of these, you want to get the habit of writing out your rule for the nth term because you use that formula for other stuff. Okay? If you put it in generic terms now, you'll be quicker at it later, like by our fourth example, when you need to use it.
Alright.
Okay. So again, writing rules for nth terms is not going to be anything that's horribly scary bad, especially if you're given the sequence and you can work from it from there. But what happens when you don't know the sequence and you got to figure out the rest? That's where things can get kind of messy. For example, in this case, I do not know what the sequence looks like. I know what the 13th term is, and I know the common difference is 1.5. I don't know why this updater doesn't work. It just doesn't want to work. And it tells me so every 4 hours it goes off. So again, what we want to do here is we always start these problems out by writing out what we know. Well, I know that the nth term is going to be the first term plus n minus 1 times my difference. Well, in this case, I know what the 13th term is. I know that a sub 13, well, that's still going to equal the first term plus 13 minus 1. And what's my difference? Times 3 over 2. So the 13th term is going to equal, which is how much? 30. So that means my first term plus, what's 3/2 of 12?
Complicated.
Times this.
18. 12 divided by 2 times 3.
It's
Okay? So what's your first term in the sequence? 12. Good. So now you know what your first term is. You know what your difference is. Now can you write out in terms of n?
Wait, how's it 12? I thought it was 18.
No?
Oh, wait. Sorry, Derek.
So my nth term is going to be 12 plus n minus 1 times 3 over 2. Again, distribute and combine like terms. We get 12 plus 3/2 n minus 3/2. 3/2 is $1.50, correct?
Right.
What's $12 subtract $1.50? 11.50. Can you break a 10? See how much change I get. Oh, I don't have 10. Oh, I do.
We talked about $100.
Oh. So how much is $12 subtract $1.50? In this example, is it the end of the world if you do 10.5?
Are we using 6 figs? That's the question.
That is the question.
That is the question, all right. To be honest with you, when you start to write out some of these formulas like this, I honestly don't think it's the end of the world for fractions that are, 50 cent, halvesies and quarters. If you do 0.5, 0.25, I don't think it's that big of a deal when you're moving stuff around. If you want to write it as 21 over 2, that's fine as well. Okay? It's a lot of work, but was it difficult work?
No, writing the fraction would be a lot of work.
Yeah, well, not really. Your calculator does it.
Really?
If you do 12 minus 3 over 2 and hit that math with the fraction bar, it should spit it out in terms of fractions.
But like typing the fraction is just a struggle usually.
Oh, I know. Pressing buttons is hard.
I usually do when
Much easier than writing.
Yeah. All right. So again, the stuff that's in this section isn't that bad. There's just little twists to it, and it's all coming back into knowing how you can manipulate this equation with the given information that you have. Let's look at another one. Now what happens when you have 2 terms? You don't know your difference.
2 chains.
You're not screwed. You're not up a creek. We'll be all right.
So your dad will get back.
No. Start with what you know. Again, you know that the generic formula would be a sub n is the first term plus the n minus 1 times your difference. You know the 6th term in this sequence is 10. So the 6th term is the first term plus 6 minus 1 times your difference. How much is the 6th term? What is its value? 10. So 10 has to equal the first term plus 5 times the difference. Okay with that? I'm going to do the exact same setup with the 21st term. Yeah, you can. So the 21st term is, again, the first term plus 21 minus 1 times it. So 55. Notice how you wind up with.
My hair's not.
Notice how you wind up with 2 equations with 2 variables. It's setting you up for solving a very short system of equations. Okay? And you'll be able to use elimination with rather quickly. I'm going to get rid of the variables.
Subtract it. Hardest thing.
When I subtract it out,
Came on.
what's your difference? 3. So your difference here winds up being 3. So now you know nope.
Put them all spin side.
Below someone is jittery.
I'm guessing you might have gone to the computer lab. Maybe. I don't know. Is there a sign on your door?
Get these children out of the hallway.
Solano just left.
They're nothing but a nuisance.
But I don't know where he is. Hi, everybody. Now, again,
You should just throw child like that.
again, we now know what the value of D is. Just substitute into here to figure out what the first term is. Yes, sir.
May I ask what's going on out there?
It looks like a couple of students walked someplace, and then their class left the classroom and didn't leave a note to tell the students where they were going.
Sociology.
So they're wandering aimlessly and pounding on windows, because when you look through the window, you can see there's nobody in there, but yet you want to pound on windows to make sure there's nobody in there.
That's what I would.
Typically crooks.
Anyway, so now what you have to wind up doing here is to figure out what your first term to write everything out. Oops. What was your first term in this sequence then? -5. So now you have your first term, your common difference, and then you put it all back together in terms of the nth rule. Again, I know this seems like there's a lot of work going on, but the actual math that you're doing is really easy. So the nth rule is your first term plus n minus 1 times 3. Distribute in, and you get -8 plus 3n. Okay?
That's easy. So,
It is, it can be, but you can see how it's very, very quickly, you can get lost in one of your problems if you're not very good at writing it out in some sort of a sequence, shall we say, on paper. Those of you guys that get lost in your handwriting, this is not going to be your favorite chapter. So try not to get lost in your handwriting. Which leads you to the last bit.
this is typical class. This is like, all right, you guys get this? Yeah. This is easy, this is nice. Bam! Check out this equation that makes no sense currently.
Because you've never seen it before.
That's what I'm saying, Mr. Murphy.
If you
Remaking
write
soda.
something down,
For salt.
you might be able to retain some of it.
I retain.
Okay, what else?
That don't make sense.
Turn up the smart board. What's it say?
Stuff.
What
Now,
this,
ready?
what this formula is saying, this is saying, this is talking about a sum. Okay? The sum is this very similar to what you guys worked with yesterday with the sigma symbol, the E. What you're doing here is the sum of some number amount of terms within a sequence can be written as the number of terms you're trying to figure out times first term plus whatever that value is within its sequence over 2. Okay? What you're looking at here is, let's say you had a sequence of numbers. You wanted to figure out how much they all add up to equal. If you think back to something that was very easy to work with, 2, 4, 6, 8, 10. If I wanted to look at that, and I wanted to figure out how much all 5 of those add up to equal, the sum of 5 of these, well, I'm looking for, I'd have to figure out what the 5th term is and substitute through. It's not as bad as it looks. For example, there's going to be 2 parts to this. We're going to write up the rule, find the sum for the first 30 terms, and then we're going to figure out how many of them it takes to add up to 175. Again, you're going to find out that the math that you're doing really isn't difficult. It's just a matter of making sure you can substitute into a formula correctly. So if I want to find the sum of the first 30 terms, that means I'm going to figure out, well, I'm working with the sum formula. So I know that the sum of however many is that times the first term plus a sub n over 2. S sub 30, good. 30 of them added up is going to be 30 times, well, what's the first term? 4. And then I have to figure out what a sub 30 is going to equal. Over 2. Because I don't know what the 30th term is in this case. Which means I need to fall back on what is the 30th term going to be out of this.
And then you go back to the other equation.
Correct. I go back to that first term plus the n minus 1 times the difference. Yeah, Shay?
Okay, so the 830 means you're trying to find out the value of the 30?
Yes, I need to figure out what the 30th term is prior to doing anything. So I use the original formula. Yeah?
Instead of doing that, you just use the total.
What do you mean? It won't get you there. It won't get you there in this case. Yes, because I'm looking for the 30th term. So I know that the first term is 4. I'm adding to that 30 minus 1. And what's my common difference here, guys? 3. So that gives me 4 plus 29 times 3, which is 91. So you wind up with 30 times the quantity, 4 plus 91, all over 2. What's half of 30? 15. So it's 15 times 95. 1145?
14.
1445. 25. One of those numbers. Again, the trickiest part here is knowing that you have to bounce between a couple of formulas. The math isn't difficult. It's just knowing that, figuring out what you're using. The idea is to make sure you bounce between knowing what subscript you're working with. I'm looking for the 30th term. I have to use the a sub n stuff. Okay. Now the weird one. Well, when you're working with the other one, you still have to figure out the equation for the formula. You'd have to figure out what the equation is for the n, the rule, the n rules. Remember how we did that yesterday when you had the summation stuff? We had to write it in terms of n. It was like n minus 1 times 2 or whatever it wanted to be. You'd have to figure out that equation before you do all that. So this allows you to do it a little bit easier if you know it's an arithmetic. It's just a little bit quicker. Okay. So the second part of this problem was figure out what value of n, how many of them you have to add together to equal 175. So what happens then, you need to figure out how many of them will get you up to 175. So you have to use the sum formula, and that equals n, first term, plus a sub n over 2. what was the first term in that sequence? No, the first term in that sequence. 4. Good. So I know that it was n 4 plus. Well, I need to figure out what that a sub n is. And Miss Daisy, this is kind of what you were talking about. Should I always write out that nth rule? This is where I need to write out the nth rule. See how I didn't do that there? I have to go back and redo that. So we were able to substitute in and get your answer, but if I wanted to write this out in terms of n, it would have been 4 plus n minus 1 times 3, which gives you 1 plus 3n. Yes. As your nth rule. Yeah.
So the 2, I can divide either number. I can divide the n without sign with the 30 divided by 2. It's easier.
Yep. So you get. Oops. So I know that 175, because that's what this is n 4 plus 1 plus 3n all over 2. What do you do first? Yeah, combine the 4 and the 1. And what do you do to get rid of that divide by 2? What's that? Yeah. Get rid of the divide by 2. You get 350. Is going to equal 5n plus 3n squared. You okay with that? Yeah.
The n after the 3n wouldn't that be 5?
No. We don't know what that is yet. We're solving for n.
Oh.
We have to figure out how many of these add up to get us to that 175. So now, factor.
Wait.
3n squared plus 5n minus 350
so much fun.
is 0. Where's your 0 then?
Oh, good.
I don't know about, you can't factor out a 3 or a 5. Can't factor out the n.
What's 3 times 350?
That's not going to get me anywhere. What's that?
Leave it like that.
Leave it like that? No.
1,050.
What times what is 1,050, negative 1,050 to add together to get positive 5?
I have no idea.
I have no flipping clue.
Probably doesn't.
Don't you have a calculator? Can't you find your 0?
I was gonna say that, but
What is it?
Negative 35 and 30. I mean, other way around.
Negative
30?
35 negative 30.
Yeah, there we go.
35, negative 30. Okay. Or, good job.
Table?
Y equals go to your table.
That's what I did.
And just take it.
Y equals go to your table. Does everybody agree in this problem you're going to have a positive 0 and a negative 0? Because you had two numbers you multiply together to get you a negative, but they add to a positive. Which one of those is going to be the right answer?
Positive.
The positive. Just go right in your table, find your 0 that's positive, and you'll find it at dun, 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 10.
10?
The answer's 10. N is 10. You have to add 10 of them together in that sequence to equal up to 175.
What was the negative?
what did you do in your head?
What's that?
What was the negative?
It's a fraction.
You're the 10.
You can't have a fractional amount.
3x squared plus 5.
If you factor that out, you'd get the same answer. It's just messier.
It's not.
You can see right here, this will be your positive 0, because the other one's a negative fraction. It's not going to work. That's about as messy as this stuff gets. We have to fall back into a little bit of factoring at the end here. Remember, anytime you have to try to get your stuff back into that a sub n is for your nth root. or not your nth term. Yes, sir.
Why when is the negative one?
Can you count? Can you have a negative fractional amount as a sequence? How many terms does it take to add up to that? Can I have negative 35 over 3 terms? That's why. You wind up looking for a positive integer on these things. That's why the table is your best friend. There's no reason to try to factor it. Just use your table. You can have a negative term, yes, but they're asking you how many of them do you have to add together. What's the value of n? How many of them in that sequence would add together to give you that value? You can't take half of one of those. Okay. What I want you to do is try a few of these tonight. This is 11.2, excuse me. Stop there. Stop. Work on those, please. About 15 maybe? Give them a shot. Okay. Should be all right.
15 questions.
Are those the issues that I did with overcame, right?
What's that going?
Oh, do we do tests now?
Yeah, I'll go get them. Just want to stop this.